Okay, this is Unit 0. This is our Alka-Seltzer Rockets lab. I'm going to step you through how to do a lab write-up so that you can get a 100 every single time. So what you're going to need to do is go to Canvas. So I'm going to open up Canvas here. And inside Canvas, you're going to see your course on chemistry. So you click that, whichever one it is, and 99.9% of everything I do is going to be listed here in modules. Now, this is my view as a teacher. If I were to go into student view, it's going to look a lot cleaner. You're going to see this, and then you're just going to see these 4 selections here. Okay, so let me exit the student view. Okay, so go into modules, and here's our Alka-Seltzer lab. See these little triangles? You can click these triangles to collapse everything that's under that unit. So we already did the unit on syllabus and safety. Remember, I stepped you through labs, tests, all of this. And then we got down here and we took our safety test. And all I need to do is hand out to you now the safety contract, because everybody made a 30 or better, 30 out of 35 or better on that. Okay, but now we're working on the Alka-Seltzer lab. So if you want to click on that and expand this, the first thing you're going to need to open is this lab write-up right here. And I give you this every single time we do a lab. So you click here and it's going to tell you to make a copy. So you click that, and this is our lab write-up right here. So let me go to 150 zoom on this. This is the template for the lab write-up. And what you're going to do is you're just going to erase these instructions and type in your stuff here. And then you're going to turn in this file to me at the end when we do our lab. Okay, so you're going to need another document. And there's several ways to get that. You can either click next here, or you can go back to modules and click Alka-Seltzer Rocket, the handout. Okay, and I'm going to zoom in on this as well. All right, so every lab that we do has a handout. It tells a little bit about the lab, the background, the purpose of the lab. It lists the materials, safety, if we have any pre-lab questions. It'll give you the procedure, and then it'll give you any data tables that you need, the post-lab questions. Okay, so this is the handout. And I usually don't run these off on paper, unless you absolutely need me to, and you can talk to me on an individual basis on that. I usually just put it on Canvas as a digital form so that we can be environmentally conscious. But those are the 2 things that you need for writing up a lab. So let's go back to here on this tab, click the template of this. So what you're going to need to do first is change this header. And so you double click here, and then you can change this header. And we're going to put in the title of the lab. Okay. And how do you know what the title is? Well, I have the same header on all of the assignments that I hand to you. Up here at the top, Aubrey High School Chemistry. Here is the unit. We're in Unit 0, Syllabus and Safety. Here's your Aubrey heading, name, class period, and date. And then right here is the name of the assignment. And so the numbers, this is Unit 0, and this is the first assignment within Unit 0. Okay, and here's the title, Alka-Seltzer Rockets. So that's what I wrote there. Okay, so let's realign these, and I'm going to erase this and type in your name. Okay, and this is always the date it is due. And so this is going to be August, let's see, today's, let's see, 28, 29, 30th, August 30th. Let me make sure, because we're going to turn this in on Monday. This is going to be due Monday. Yep, August 30th. All right, so this is August 30th. Okay, now this is what's called predictive text. I haven't typed that yet, but Google is predicting what I want there. And if you want to accept this, then you just push tab. Okay, and it shortened the month, abbreviated the month. Okay, and this is chemistry, and you're just going to put your class period, so I'm just going to put 1 there. All right, so we have our header done. Let's double click down here in the main body, and we can start typing. All right, so for the purpose, it says, what is the reason we are doing this lab? What are we trying to find out? This information is usually provided for you in the lab handout. You must read and infer. You may not copy and paste. That's plagiarism, and we don't do that. We get zeros for that. And that's not only copying and pasting the original but it's copying and pasting each other's work as well. Do not do that. You need to put this in your own beautiful words. This is where you establish the dependent and the independent variables in the lab. Okay. Pardon. Okay, let's talk about the dependent and independent variables. So let's go back to here. All right, the dependent and independent variables in an experiment. There's an easy way to remember this. And the easy way to remember all of this is the acronym DRY mix. And so that's really a thing. So if you're into cooking, a dry mix is like a dry powdery mix that you can get that you just have to add water to make, or add something, one item to make the dish that you want. For example, going down the pancake aisle at Walmart, you'll see the pancake syrup, etc., but you'll see also boxes of pancake mix. And if you look at the back of this box, in order to make that mix, you just need to add water or milk. That's all you need to add, just that one ingredient, that liquid ingredient. It contains everything else in the mix to make pancakes. So if you're going to make pancakes from scratch, you're going to need flour, baking powder, salt, sugar, eggs, milk, all of those, vanilla, all of those ingredients. But in a dry mix, it's all in there for you, and you just add the liquid. Okay, so that's what a dry mix is. All right, but for the purposes of experiments, if you just remember this dry mix, it's an acronym for the D is the dependent variable. Okay, the R stands for the dependent variable, is also called the responding variable. Okay, and we're going to skip the Y for now. So the responding variable, the dependent variable, it responds to a change that was made in experimentation. So let's look at mix. M stands for manipulated variable. So the word manipulated means controlled or changed. So this is the variable that you're going to control and change. And when you make this change, some kind of response is going to happen. So the dependent variable is dependent on the change that's made in the experiment. All right, so the manipulated variable is also called the independent variable. Okay, so this is the one that you're controlling and that you're changing. And then this is responding to that change. All right, so the Y and the X, this is when you're graphing your data. Okay, so the dependent variable always goes on the Y-axis, and the independent variable always goes on the X-axis. Okay, so going back to there you go. Going back to our write-up, it says that for the purpose of this, we need to establish the independent and dependent variable. So we're going to read our handout here, and it's right here in the introduction. You'll be using a white plastic film canister and, Alka-Seltzer tablets to create a rocket. You will be testing, here it is, the effect of water temperature on the rate of reaction between water and the Alka-Seltzer tablet. Okay, so there's our purpose. Do we have a dependent independent variable? Yes, the effect of water temperature on the rate of reaction in the tablet. Okay, so I'm going to go back to my handout here. Actually, I want to rename this. Oh, this is already copied. So let me rename this Alka-Seltzer Rocket. Okay, so it doesn't save over anything. All right, so when I'm ready to type, you need to make sure that you delete these instructions and type. So all you want is what's highlighted there. That's the different sections. Okay, so the purpose, let me move my tablet here. The purpose, and we're writing in complete sentences. We are 10th graders, and we are more than capable of writing in complete sentences. Okay, the purpose of this lab is to test the effect of water temperature on the reaction rate of, okay, so you see the predictive text. I just push tab. No, let's say on Alka-Seltzer tablets. Okay, so the purpose of this lab is to test. Okay, so when you see something underlined, that means that it thinks you've made a mistake in grammar or spelling and you need to correct that. Blue is grammar, red is spelling. The purpose of this lab is to test the effect of water temperature on the reaction rate of Alka-Seltzer tablets. Okay, so you want to make sure that you proofread and get this right. Okay, so we've named our two variables there, water temperature and reaction rate. All right, so we're good on that. All right, background. You should write as many notes from the background information on this lab sheet that you think necessary to support the reasoning behind your hypothesis. So the hypothesis is the next thing that we're going to do after the background. Again, you may not copy and paste. That's a misspelling. I'll correct that later. All right, so I'm going to erase this. Okay, and so here we're going to go back to our handout, and this is the background information. So what you're going to do is you're going to read the background information, and you're going to interpret that, and you're going to write it in your own words. All right, so first of all, we know that the most common effervescing tablet used in film canister rockets is Alka-Seltzer. In fact, the company that makes Alka-Seltzer is so proud of the fact that it can be used in science experiments that they have a whole page on their website dedicated to it. Okay, so yeah. Big deal. That's just an introduction, right? That doesn't have anything to do with the actual experiment. When you mix these effervescing tablets with water, a chemical reaction takes place between the citric acid and sodium bicarbonate contained in the tablet and the water. Okay, so there it's telling us a chemical reaction takes place. That's chemistry. And it's given us names of compounds that are reacting. So that's pretty important, this information. So I'm going to go over to my lab here and I'm going to start writing this. So the chemicals in Alka-Seltzer tablets are citric acid and sodium bicarbonate. When this tablet is placed in water, a chemical reaction takes place between the two chemicals. All right. So I did not copy and paste that, but what I did was I read this and then I came over here and wrote it in my own words. Okay. You saw me. I didn't look back at this. I read it and then I just wrote what it said in my own words. Now, I don't expect you to remember citric acid and sodium bicarbonate, big words like this, chemicals. So you can look back at how to get the spellings of those, but write it in your own words. These are my own words that came out of my head from my thoughts. Okay. All right. So let's continue on. This chemical reaction creates many, many bubbles of carbon dioxide. Okay. So as this chemical reaction takes place, carbon dioxide gas is released. Okay. Citric acid is a weak acid and is in the juice of most citrus fruits like lemons and limes. Sodium bicarbonate is basically baking soda. You can achieve the same results by mixing baking soda with any acid like vinegar. So vinegar is called acetic acid. So you may have done this when you made your like volcanoes in elementary school. You mix baking soda and vinegar and it foams up, a lot of foam. So it's the same thing. All right. So do we need to put that in? Let's see. So we can say something like citric acid is found in citrus fruits. Okay, and name lemon and limes, but we know more citrus fruits than that. So let's name a different citrus fruit, like oranges. Orange is a citrus fruit. You could have named any other citrus fruit. Okay. Citric acid is found in citrus fruits like oranges, and sodium bicarbonate is just baking soda. Okay. So we don't need to say anything about the reaction with any acid. Okay. I mean, you can if you want, but it's not necessary. So we got a lot of information. How many sentences? 1, 2, 3, 4 sentences out of that. Well, let me show you something. I'm going to go back to here. Actually, I'm going to download this because I'm going to switch between different programs. Okay, so there is this downloaded. I'm going to 175 is good. So now I can go to a different spot on here. I just want to show you down here at the bottom, this Alka-Seltzer lab. This is the rubric that you're going to be graded by. So what is the reason that we're doing this lab? This right here, this criteria. What are you trying to find out? This information is usually provided in the lab handout. That's the same wording that was on your instructions here under the purpose. Like say, for example, hypothesis. In science, a hypothesis is an idea, blah, blah, blah. Okay, in science, a hypothesis is an idea, blah, blah, blah. Okay, so that's the same instructions. So here are how you get your points. So for the purpose here, it's either 0 points, 2 to 0, 5 to 2, 8 to 5, or 10 to 8, all of the points here. So it tells you what you have to do to get this amount of points. Okay. So 0 points, nothing written or just the instructions were left in the template. So that means you didn't write a purpose You just left the instructions there. Or maybe you deleted the instructions, but it was blank after that. So 0 points for that. All right, all the way up to 10 points, both variables stated. So did we state both variables? Water temperature, reaction rate, okay? And a clear relationship between the variables was stated for testing. So the effect of water temperature on the rate of reaction of Alka-Seltzer. Okay, so we just didn't list two variables and stop. We explained in complete sentences the relationship between the water temperature and reaction rate. We're testing the effect of water temperature on the reaction rate of Alka-Seltzer tablets. Okay, so you're not going to get full points just for writing the two variables. You have to establish the relationship. Okay, so on the background information that we're writing right now, nothing was 0 points, nothing was written, or just the instructions were left in the template, all the way up to enough information was written to fully support your hypothesis. At least 2 paragraphs of 4 sentences. So that's 8 sentences that you need to write. 2 paragraphs of 4 sentences. Okay, so here we have, let me see. I'm going to go ahead and put this in underneath like that. You don't have to put it starting beside. All right, so we have a paragraph here where we've already started. Okay, so I'm going to hit enter and I'm going to start a new paragraph because it says 2 paragraphs of 4 sentences. Well, we already have, what do we count? 1, 2, 3, 4. Okay, so we just need 4 more sentences really to get full points. But just because we write 4 more sentences, if we don't finish summarizing all this background, does that mean we're done? No, we finish summarizing even if it takes us 10, 12 sentences. Okay, don't just stop once you get 8 sentences. Okay, so let's go back to here. Actually, let's go back to here because we're ready to go to this next one. All right, so why does the rocket go up? It goes up because the gas is building up in a closed film canister, and since the lid is the weakest point of the canister, the lid pops off, and all of that gas comes rushing out of the end of the canister. This action can be explained by using Newton's third law of motion. More specifically, is an example of Newton's third law of motion. Every action has an equal and opposite reaction. All right, so I'm going to stop there, and I'm going to come over here, and I'm going to say this rocket works because of the concept of Newton's third law of motion, which states that, and I'm going to go back and look. For every action, there's an opposite and equal reaction. For every action, there is an equal and opposite reaction. When the gas builds up in the canister, eventually the lid pops off and gas rushes out of the canister. Sending the other part of the canister up. Okay, so there's 2 more sentences. All right, we stopped right here. The gas rushing out of one end of the canister causes the rocket to move in the opposite direction, the reaction. This is exactly how rockets work, whether you're using effervescing tablets or your fuel or a chemical rocket propellant like they do at NASA. Okay? All right. So we could come back here and say, this is exactly how NASA rockets work too. Okay. All right. So now we're moving on to this one. Do we want to make a new paragraph? Well, we have 1, 2, 3 sentences, so we could. Okay. So just because the rubric says 2 paragraphs doesn't mean we can't do 3, right? So if this is a whole separate section, like say we have 3 sections, we have our first section, second section, third section, we can have 3 paragraphs. Okay. Each section that we read can be a separate paragraph. Or if there's just one section, each paragraph we can make another paragraph, or we can combine these 2 paragraphs into one paragraph. Okay. It just depends on how you do your writing. All right. Quite simply, rockets are how NASA can get all those amazing missions off the ground. These rockets use a pressurized fuel and an oxidizer. The oxidizer is something that allows the fuel to burn without using outside air because it's in space, right? There's no air in space. So you have to have an oxidizer to supply the oxygen. The fuel is in a gaseous state, is pressurized because this forces it out of the end of the rocket, just like the film canister rocket. However, there are a few more parts in an actual rocket. It's not as simple as like we're making it with the film canisters. Okay, so that's just background information. That's really not important. So here's the meat, I guess, of the paragraph here. The fuel used in the rockets, like the ones that help the astronauts to the space station, use liquid hydrogen as a fuel and liquid oxygen as the oxidizer. You may be saying to yourself, well, I thought you just said that the fuel is in the gaseous state, not liquid. Well, you're right. The fuel and oxidizer are only in these liquid states when they're in the holding tanks. They're being stored in the rocket. And they can only stay in this liquid state at extremely low temperatures. So the fuel and the oxidizer are allowed to combine in a separate section of the rocket called the combustion chamber. And as they burn, they turn into gas. So this is kind of like the same thing that happens in your car engine. We store the fuel in our car in the gas tank, right? And then when this fuel is brought up to the engine through hoses and tubes, it goes through a device called an injection system, and it injects the liquid fuel into the chamber. It's called a piston chamber, where it's hot in there. And so the liquid immediately turns to gas. And then the piston pushes up and compresses the gas. And then the spark plug sparks, which causes the gas to explode. And as the gas explodes, that's where we've gotten so far, that they burn, the gas burns. But because it's compressed, it burns. It burns, but okay. Let's just read. Gases take up 1,000 times more space than the liquid, and this is what causes the intense pressure. Okay, so that's what I mean by explode. So the gas in the chamber, when it burns, it expands, and it's 1,000 times more space than the liquid. So it explodes the piston downward, and that's what the piston is connected to a crank, and it turns. And as this crank turns, that's what causes the wheels to turn. I mean, it's a lot more complicated than that, but I hope you get the idea. So in a rocket, when this fuel burns and turns into the gaseous state, it's 1,000 times. It takes up 1,000 times more space than the liquid. Well, the combustion chamber is pretty small. So when the gas expands, at the bottom of this chamber is a little hole called a nozzle. That's the only place for the gas to escape. So the gas rushes out of this hole in the bottom of the rocket so fast that it pushes down on whatever it is, like when it's lifting off the ground, this gas pushes down on the ground, and that's the reaction. I'm sorry, that's the action. And then so the reaction is that the rocket's going to go up because the force is pushing down. The opposite direction is up, so the rocket's going to go up. Okay, so we need to summarize this into here. So we can say that as the reaction takes place between the water and the Alka-Seltzer, the carbon dioxide bubbles take up 1,000 times more space than the liquid or solid, and eventually the top of the canister pops off, sending the other part of the canister upwards, like burning liquid fuel in a real rocket. Okay. All right, let's see. Oh, well, it just summarized it down here. So we got a little ahead of ourselves. Okay, so how many sentences do we have for this paragraph? So this is one long sentence. We need to break this up because that's a run-on. Okay, as the reaction takes place between the Alka-Seltzer, between the water and the Alka-Seltzer, the carbon dioxide takes up 1,000, bubbles take up 1,000 times more space than the liquid or solid. Okay, there we go. So the word "and" is a conjunction combining these two sentences. So we can take that out and make this a whole nother sentence. Eventually, comma, the top of the canister pops off, sending the other part of the canister upwards. Okay, so two sentences can make up a paragraph. So there we have our paragraph. Okay, so we have, what's the criteria? Let's see, let me find it. The criteria, two paragraphs of 4 sentences. Do we meet that criteria? Well, we have 3 paragraphs, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sentences. Okay, so we have met the criteria, and as long as we didn't copy and paste or plagiarize, then we will get full points for this section. Okay, so that's the background. All right, so let's move on to the hypothesis. In science, a hypothesis is an ideal or explanation that you will then test. The hypothesis must include an independent and a dependent variable. Remember dry mix? This should be written as an if-then statement. And then I give you an example. If I give a plant an unlimited amount of sunlight, then the plant will grow to its largest size. All right, so we need to erase this and write in our hypothesis. Okay, so we have to name our 2 variables. So which variable are we manipulating? That's going to be the water temperature. So we can say if we use, and we can choose one of 3 temperatures: hot water, cold water, or regular room temperature water. So let's just use the extremes, either hot or cold. So choose one. You don't have to choose the same one I do. You could choose the opposite one. If we use, I'm going to say hot water. if we use hot water, then there's their if and then the, what's the other variable? Reaction rate. Then the reaction rate of the Alka-Seltzer will, and reaction rate, the rate of a reaction, rates are measured in time. Time, the unit for time is seconds. So we can say here that the reaction rate, if we use hot water, will increase or decrease. There'll be more time or less time. Will take more time, okay, or increase. All right, so there we have our two variables that we stated, and we have established a relationship. We chose one of the variables. If we use hot water, then the reaction rate of the Alka-Seltzer will take more time or increase. The reaction rate will increase. All right, so we can test that, and that's exactly what we're going to do. So your hypothesis needs to be testable and measurable. Okay, we can measure hot water using temperature, a Celsius temperature probe, and we can measure reaction rate by using a timer in seconds. So we have a good hypothesis there. Okay, so correctly written as an if-then statement. This is the only thing that's written in this section of the lab, no grammatical errors. Okay, so we just write the if-then statement without any grammatical errors, and you're going to get full points. How many points is that? 10 points. Okay, because that's pretty important, knowing what you're testing and knowing how to write a hypothesis. So is the purpose of the lab. Knowing the purpose of the lab, 10 points. That's pretty important. Now, let me show you this. The other important part here is your data and your conclusion. Look, conclusion, 20 points, data, 25. These are very important parts of your lab, okay? And so that's why they're worth more points, okay? This, you're having to write the purpose. You're having to write your own sentences without plagiarizing. Here, the background, you're writing without plagiarizing. So that's a lot of points. Your hypothesis, you're coming up with out of your own head without plagiarizing. Now look at this. Materials. This is a simple list of the materials needed for the experiment. Okay, there's no interpretation there. There's nothing that you have to read and interpret and write in your own words. This is just your materials. You can copy and paste this. So I'm going to copy this, and I'm going to come over here, and I'm going to Control Shift V, not just Control V, but Control Shift V, because I want to keep this same formatting that I've got going here. And that's what the Shift does. If you just did Control V, then it's going to also copy over like the formatting of the text. So I'm going to keep the formatting the same as my paper that I'm writing. So I use Control Shift V. All right. So there are my materials. Now look, materials. This is a simple list of materials needed, correctly including only the materials and no instructions left in from the template. So I've erased the instructions from the template and copied in 2 points. So you don't have to interpret here. This is just copy and paste. So 2 points. I mean, I'm giving you 2 points to verify that you can copy something and paste it in. That's, you don't have to do any thinking there or interpreting or writing in your own words. So 2 points, it's not worth that much. So, all right. And then same thing here with the safety. Okay. You don't have to read and interpret. You just have to come over here and look at the safety, goggles and aprons, copy and paste that in. Control C, Control Shift V, goggles and aprons. All right. Pre-lab questions. This is a section where you'll write and answer any pre-lab questions in the lab. Some labs do not have pre-lab questions. In this case, you're just going to leave this section out. So you just highlight this whole thing if it doesn't have pre-lab questions and erase. So you go from safety to procedure. So let's look. Do we have any pre-lab questions? We do. Right here, pre-lab questions. So I don't want to erase this section. So I do want to erase the instructions though. Okay, and I'm going to go on down to the next line. I'm going to come over here, and you can just copy and paste these pre-lab questions. So Control C, go back over here, Control Shift V. Okay, and I didn't get my 1, so there you go. All right, so we had to have the question and the answer. Question and answer. So there are my questions. I just need to answer it. All right. I'm going to tab over before I write the answer. So what does the acronym dry mix refer to when graphing your data? Okay, so graphing your data, remember that was the Y of dry and the X of mix, graphing data. So the dependent variable will be graphed on the dependent, so dependent on the y-axis. So I'm going to put y-axis, and the independent variable will be graphed on the x-axis. Okay, so let's go ahead and keep, oops. Oh, you have to go over here, backspace, and hit enter, and then it'll line it up like it's supposed to. Okay, so there's my answer, and I indented it a little just to separate it from the question. Okay, so let's go down here, tab. What variable is the manipulated variable in this experiment? All right, so remember the manipulated variable is the one that we're changing, the one that we're controlling. So that's going to be, writing complete sentences, the manipulated variable is the water temperature. Okay, there you go. Make sure you're writing complete sentences. We're in high school. What is a line of best fit when graphing data mean? Okay, so I know that you know what this means because we teachers talk to each other. And I talk to your math teachers, Algebra 1, and they assure me that you know what a line of best fit is. So let's review that. So the x-axis is the manipulated variable. So we're manipulating temperature. So I'm going to put that here. And the time is what's responding. All right. So at low temperatures, we are going to have, let's just say we have some dots here. Okay. So you're going to get data from each group. So 1, 2, 3, 4, 5. You're going to have 6 data points here. 1, 2, 3, 4, 5, 6. You'll have 6 here, and let's say you 6 here. Okay, line of best fit. Line of best fit. So the definition of a line of best fit is, if you haven't thought about this in your head, like when I told you that you should know about this, a straight line that approximates the data. It goes through all the data. So I am going to do this. All right, so some data points above, some data points below. Okay, so it approximates all your data. This is the line of best fit. Okay, so this is also sometimes called a trend line. Like if you go online to a graphing program that you're going to use to graph your data, which you can do. I don't mind. You don't have to hand draw these graphs. You can go on a graphing, like there's a website called Graph It. You can go on there, but you have to draw a line of best fit on that graphing program. That's called a trend line. So I don't think it's called a line of best fit on there, but they're the same thing. All right. So this is a line of best fit. So let's go back to our paper. Where is it? Okay. What is a line of best fit when graphing data mean? Okay, so a line of best fit is a straight line that goes through all of the data groups is what we'll say. So it doesn't go through all the data points, it goes through all the data groups. All right, so we are not going to connect the dots. That is wrong. Don't do that. All right, so we have our pre-lab questions. We've answered our pre-lab questions to the best of our knowledge. And so now this next section here is the procedure. And it says here, this is where you're going to copy and paste the procedure from the lab. Yes, you can copy and paste here. However, if there are corrections that I make from the original lab, you must make these corrections in the document and highlight the corrections. So sometimes I make corrections. Like sometimes I may say instead of 80 degrees here, that it needs to be 90. But the original document says 80. But I found out through me doing this that it really needs to be higher than that 90. So you're going to correct that in your lab when you turn it in. Okay, something like that. All right, so we can copy and paste this. So I'm going to go back here. Where's procedure? Right here. So I am going to delete that. And I am going to come over here and copy this. Control C. Come back over here. I'm going to get a new line. Control Shift V. Okay, now since it's splitting this up, I'm going to go ahead and put in extra space here just to make it look prettier. Is that really number one? It is. Okay. I thought maybe it didn't paste in correctly. Okay, so here I had to clean this up a little bit. Don't want to do that. There you go. And this one, clean it up a little bit so it doesn't paste in perfectly. Okay, so we've cleaned that up just a little bit. Now this should be like a degree symbol. So that is superscripted. Oh, there it is, superscript. So I'm formatting the text and I want to superscript that. So there you go. Now it looks like a degree mark. Okay, and these are just little tweaks, little details that you can make that just increase the likelihood of you getting all the points in your lab. Okay. Okay, so procedure there looks pretty good. All right, so the next part is your data, and it says, oops, Control Z, I didn't read that. Here's where you insert data tables and graphs as needed. Okay, so we're going to get those from our lab. So let's go back and look at our lab handout. And the only thing we need here is this data table. Now, you can't copy and paste this data table over. You can see it won't let you copy and paste a table. So you're just going to have to redraw it. So you're going to have to use the insert a table function here to redraw that. So we need to count how many columns we have versus how many rows we have because tables are inserted columns and rows. So we've got one, I'm counting columns. Columns go up and down. 1, 2, 3, 4, 5, 6, 7 columns. And it looks like we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Maybe this is 2 put together. So 1, 2, 1, 2, no, it's 2, 3, 4, 5. So 5, 7 by 5. So here we're going to go insert a table and we're going to do 7 by 5. There you go, just like that. Okay. All right. And so let's start from the bottom and work your way up because it looks like these are nice columns and rows here at the bottom. So hot, tap, and ice go in the first. So hot water. And tap water just means it comes out of the faucet, out of the tap. Or you could say room temperature water, it doesn't matter. Ice water, okay? And then, so we have these 3 that are blank here because that's where you're going to add your data in. And so up here is going to be your group, second group, third group. Okay, so your group, oops, second group, third group. Okay. And that is for temperature, and we're going to do the same thing with the time. So your group, second group, third group. Okay. All right. Now it looks like these three columns have been merged. These three cells have been merged together to make one cell. So let me show you how to do that. So these three cells have been merged together. So you want to go to Format, Table, and merge these cells. So now it merged those together, and it looks like these three have been merged together. See right here for reaction time. So I want to go Format, Table, Merge for reaction time. Okay, so this is temperature, and this said it was in degrees Celsius. So I'll just use a lowercase o, and then I'm going to highlight that, and I want to format this text into superscript. There you go. And what was this one? Reaction time in seconds. Okay, now let's just make this pretty. Let's take these and center them. And we could even take these and center the text too within the cell. All right, and then finally, these two cells have been combined to say water. So again, how do you combine them? Format, Table, Merge cells. Okay, and then we type water in here, and it looks like that's fancy. It's in the center and the center this way, sideways, and center up and down. So let's see, that's sideways. This looks like up and down. Nope, that's just the line spacing. I know there's a way to center it up and down. Let's look at this. Format, Table. Let's go to Table Properties. Vertical alignment. All right, cell vertical alignment. We just say middle, because that's what that's called, is vertical. Vertical is up and down. Horizontal is across, like the horizon. You know what the horizon is, where the sky meets the land. Horizon, horizontal. So that's how I remember that a horizontal line goes from left to right, straight across. So vertical is the opposite of that. Vertical means up and down. So vertical alignment, let's say middle. Boom, we did it. Okay, so that's vertical alignment. So you have to go under Format, the Table, and then Table Properties to get to that. So there's always a way to do it. You just got to figure it out. All right, so that looks pretty good. That looks almost exactly like that, and I'm happy with it. It doesn't have to be like a super duper exact match. It gets the job done. All right, so see this line right here? This is where you stop for the pre-lab. So when I say have your pre-lab done before we do a lab, because I'm going to check your pre-lab, that's what this is. It's the purpose, background, hypothesis, materials, safety, pre-lab questions, procedure, and your data table drawn. This line means that's where you stop until we actually conduct the lab. Now, we need to take that line out, okay? Oh, we need to delete the instructions too. It says everything above this line should be done before you come to class. That's what I just said. Okay. All right. So those are instructions. I need to take those out. Okay. So actually, there you go. All right. That looks good. Spacing's good. All right. So now we just have to wait until we do the lab. So this is the pre-lab. This pre-lab is done. When you come into lab, you're going to gather this data, right? Your temperature for your ice water, and the time, tap water, time, hot water, time. You're going to trade data with 2 other groups. So you get to choose 2 other groups. You're going to record their data to fill out your data table. And then we're ready to do the rest of the lab. This is called your post lab, and you need to do this to finish up. Okay. So if you are doing this makeup lab, you need to go to, where is it? Okay. Right here. So this is the rubric. So again, go to modules. Okay. And here's the lab video. So this is actually me doing the lab here. And you just click play.
Okay, here's the Alka-Seltzer Rocket Lab.
And I'm actually doing the lab here. And you can make this bigger.
There's ice in here. I'm going to put water in these.
Okay. And this is what we actually did in class. And I'm going to be doing the lab for you. I'm not going to, this is 8 minutes long. I'm not going to play the whole thing. Okay, but you get the idea. And at the end of this lab, the very end, right here, oh no. That's not what I wanted. All right, so let's go back. Modules, Alka-Seltzer. Oops. Click the wrong thing, sorry. Video.
Okay, here's the Alka-Seltzer Rocket Lab.
Now let me show you something.
1.91.
When you get down to the end of the lab.
That was quick. All right, so there you have it. If you will wait just one moment, you will see the data for 6 other groups come up on your screen. You can write those down and remember to use that for your post lab to do your graphing. Okay,
so here it is. All right, so you pause the video right here, and this is what I said, 6 other groups. So you have 1, 2, 3, 4, 5, and yours. So you can just pick 3 of these. It doesn't matter which 3 you pick, just pick 3 of those and complete your data table. So you're gonna have to pause because it doesn't stay up on the screen for very long. So remember to pause that so you can write this information down. Okay? And then once you get this filled out, then you can do the post-lab questions. Okay, so let's go look at your post-lab questions. Okay, so again, you're going to write the question and the answer. And I happen to know there are post-lab questions. So here they are. Okay, so Control C. And come over here, Control Shift V, and there they are. Let me clean this up a little. There you go. All right, so there are your post-lab questions. I'm not going to go through these and answer these for you, but you're going to do the same thing. Okay, so just tab over. What is the dependent variable? The dependent variable in this lab is... and then whatever the answer is, right? Okay. And here it says, what are the 3 qualitative observations you made in this experiment? All right, so it's using the word qualitative observations. If you don't remember what that is, you should know what that is from 8th grade and 7th grade. If you don't remember what that is, just because I didn't talk about it does not mean that you shouldn't be responsible for it. We are in the 2021 year. We have had internet for as long as you have been alive. Use it. Okay, so copy. Let's go to Google. Paste. Qualitative observations definition. A qualitative observation involves the use of 5 sensory organs, sight, smell, taste, touch, and hearing, and their function to examine attributes or characteristics. Being subjective in nature, it focuses on characteristics and qualities of variables rather than numerical values. All right, so it's using your 5 senses to make observations, not numerical values. Okay, so Let's see, what are 3 qualitative observations you made about this experiment? All right, so 3 qualitative observations, something that you used your senses for. Okay, so think about it. 3 things, observations you made about this lab that don't require numbers, that they do require your senses. Okay, so that's how you answer those questions, where I don't necessarily outwardly give you the answers that when we were talking about this in class. Okay. All right. And the last one here, it says gather data from 2 other lab groups and graph the data from this experiment using a line of best fit for the data. Use a separate sheet of paper. You can use a separate sheet of paper, and it says glue it in your lab book. This is when we used to do lab books. We don't do lab books anymore. So you can either draw this on graph paper. I don't want you to use notebook paper and make your own lines. I want you to either use graph paper, or you can go to a graphing website. Okay, and there's, let's see, graphing calculator demos, create a graph right here. So you can go to places like this and create a graph. And this is not a bar graph. It's not an area pie graph. So maybe a line graph. Okay. And if you haven't used one of these, then it's going to, there's going to be a learning curve here. It may take you, I don't know, 30, 40 minutes to make this simple little graph in a program like this that you have no idea how to use. You've never used it before, or you can draw your own. It doesn't matter to me. Either way, if you draw your own, just make sure that you do it on graph paper. Okay. Graph paper was part of your school supplies that you're supposed to have. So yeah, you can do that. And then what you're going to do is snap a picture of it with your phone. Make sure it's close up. Don't like chicken in the grass picture. Get close to it with your phone. And then you can insert that picture into this document. Okay. Insert image. Okay. Uploaded from your computer. Save it to your computer. Or if you have a camera on your computer that you're typing this up on, finishing this up on. If you're finishing it up on your phone, then you can just go ahead and use the camera on your phone. All right. So you can either draw this through a graphing program, or you can draw it on your own paper. Now, just remember to draw the graph correctly. Now, what do I mean by that? Well, let's go back to here. All right, and I'm going to go to a new page because I want to talk to you about graphing. I know for a fact that I'm just going to see when you try to use paper, unlined graph paper, the lines are just all wonky. Okay, so what is this? Is let's see, temperature is the manipulative variable. Time is the dependent variable. So it goes over here. All right. So what's the lowest temperature that you had? Okay. So that's going to be like maybe 3 degrees. So we can start this at 0. Okay. And then you have your intervals that are set. Your lines on your graph paper are at certain intervals. Now, this is why I want you to use graph paper, because the spacing between these lines that I've drawn is not consistent. Like this one is, these two are smaller than this one. So that's why you use graph paper, so that your graph comes out looking like it's supposed to. Okay, what's the highest temperature you had? Maybe 80. All right, so I'm going to put that over here. And then so I've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That doesn't work out. So 10, 20, 30, 40, 50, 60, 70, 80. Okay, so the way I've drawn this, that may work out to go by tens. The lines on your paper, since it's tiny, tiny little graph paper, you might want to go by twos, 2, 4, 6, 8, 10, 12, blah, blah, blah. Okay. Don't make your graph little bitty tiny like this. Don't do that. Okay. So what I'm saying is the lines on your graph paper don't go by 10 because you're going to have 8 little lines like this because those are little on your graph paper. Okay. And then you're going to be drawing a graph that looks like the size of a quarter. That's no. Okay. You need to spread this out. The more it's spread out, the better. All right. So, and I can, because I am working on computer, can do that. All right. And so on the time, what's your lowest time that you had? Maybe a couple of seconds. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. I don't know. Okay. So you see these marks are a lot closer together than these marks. That doesn't work. That's why you use graph paper. Because my graph, if I were to use this like that, it's not going to come out looking correct. Okay. So let's just say 10 degrees, 20, 30, 40, 50, 60, 70. Okay, and this is 2, 4, 6, 8. These are by twos. That didn't come out looking like a 4. All right, so let's say your water temperature was 3 degrees. Okay, and it took like 50 seconds. So 2 degrees is going to be like right here. And oh gosh, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. It's the top one. Okay, so we're going to make a point right there. And say the other group was 8 degrees. And they're not very good. They didn't measure the time very good. 8 degrees and it took 40 seconds. So that's going to be about right here. And then let's say 5 degrees and it was 48 seconds. Okay, so there are your 3 dots. And let's say that your room temperature water was about 30 degrees Celsius. And that took about 25 seconds. So you're going to have here. And then the other group's going to be about here. And the other group's going to be about here. And then let's say your hot water was about 80 degrees, because I said it had to be at least 80 degrees, right? So let's say you pull it off real quick and it was 80 degrees, and that took like 1 second. So you're going to have here 2 seconds, maybe 3.5 seconds here. So you're going to have these. All right. So line of best fit, what you're going to do is you want it to go above and below equally. So I started up there. So it's about there because you have this cluster that's below and this cluster that's above. So that's the line that best fits the data. Okay. And so this is like the graph that you're going to draw. So you want to snap a picture of that and insert it, or if you use a graphing program, you're going to actually take a screenshot of that and insert it into your lab write-up. Okay, and that's for question 6 here. So that's how you would answer question 6, is inserting your data, inserting your graph. All right, so here's the big deal, conclusion. I know this is a long video, but that's okay, because you can start and stop it. You're going to need this to complete your lab. Conclusion. It says, this is a detailed paragraph or paragraphs that address your hypothesis. Was your hypothesis supported or unsupported? Explain why. What did your data tell you? All right, so that's the first part of your conclusion. Now, what I'm going to do, just so I don't have to remember what each one of these say, is I'm going to leave my instructions until I write my conclusion, and then I'm going to delete the instructions out. Okay, so was your hypothesis supported? or not supported. So I'm going to go back up here to my hypothesis, and I'm going to copy this. And I'm going to come down here to my conclusion here, and I'm going to say my hypothesis was, comma, open quotes, Control-Shift-V, close quotes. My hypothesis was if we use hot water, then the reaction time of the Alka-Seltzer will take more time. And this hypothesis was, okay, we don't say true or false, correct, incorrect. No, 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 no. We do not prove or disprove a hypothesis. We support or not support. That's the only words that I want you to use here. Okay? My hypothesis was if we use hot water, then the reaction time will take more time. Is that true? No, it took less time. If we use hot water, then the reaction time will take less time. So my hypothesis was not supported because the time on the hot water was much less time than the cold water. The cold water reaction time, the cold water at 3 degrees Celsius was, and the reason I wrote degrees Celsius instead of the little sign degrees Celsius is because it's easier to write. Now I could have done this, 3 degrees Celsius, and then gone in and highlighted that and formatted my text to be superscript. All right, so that's Control plus when I want a superscript. Oh, Control plus the period. Control plus a period. So, I mean, I can remember that keystroke, or I could do that, or I could just type out 3 degrees Celsius. All right, so the cold water is 3 degrees Celsius, and the reaction time was 55 seconds, while the hot water was at 89 degrees Celsius and took only 1 second reaction time. All right, so there I supplied whether my hypothesis was supported or unsupported, and I explained why. What did your data tell you? This is what my data told me. That was my data. Okay, so I just didn't say it was supported or unsupported and left it at that. No, no, no. Detailed, and I put it in all caps, detailed paragraph addressing your hypothesis. All right, was your hypothesis supported or unsupported, and explain why. What did your data tell you? And you can do this. You're more than capable of doing what I just did. Okay? All right. So next, possible sources of error. Okay? Some possible sources of error in this experiment were, okay, so what, as the experimenter, as the scientist, what are some possible mistakes? Error means mistakes. Mistakes you could have made in this experiment. Okay, I'm going to give you one. You cannot use the one that I give you. You have to think of your own, but I'm going to give you one as example. Some possible sources of error in this experiment were not measuring the 15 milliliters of water correctly by getting down to eye level with the graduated cylinder. Okay, so when you measure water in a graduated cylinder, you're supposed to kneel down and get at eye level. Okay, so a possible source of error in this experiment is not measuring that correctly, not getting exactly 15 milliliters of water. Okay, so you need to come up with your own, think of your own. Okay, it says possible sources of error. So that's plural, that means at least two that you need to come up with. Okay. I'm not going to take a second one away from you. I did take away the not measuring correctly. So you can't use that one in yours, but there are many, many, many other mistakes that you could have made. All right. How can this lab be improved or changed to produce different or better results? Okay. And you can't say none. This lab was perfect. There's nothing that you could do to change this because there's always something you can do to change the lab. All right, so this lab could be changed by, I'm just going to give you a way that it could be changed, that you can't use this one. This is really far-fetched, but it's a way that you could change it. This lab could be changed by using milk instead of water to obtain different results. Okay. Complete sentences. Change to produce better or different results. This lab can be changed by using milk instead of water to obtain different results. All right. Lastly, you need to research and discuss one career where the ideas in this lab could be applied and tell how they could be applied, and you must provide your sources. Do not give me a numbered list like above. So don't do 1, my hypothesis was unsupported. 2, a possible source of error. Don't do that. So don't delete these and have numbers. This is a written paragraph or paragraphs, okay, stating this information, okay? So I'm going to say one possible career where this idea could be applied is a chemical fuel developer. Okay, and so what I've actually done is I've thought of something in my head, and chemical fuel developer. Let's see if we have any. Chemical fuel developer. Is ammonia the fuel of the future? Advanced engine and fuel systems development. Okay. Fuel systems development. Okay, so let's see if I want to read this. Okay. So, oh, nope, I don't, because it's going to charge me money. Don't do that. So, fuel systems development. Let's type in that. Fuel systems development. Hydrogen and fuel systems. Researchers use electrolyzed stack evaluation platform to examine the issues related to renewable energy sources for providing hydrogen via the electrolysis of water. Energy Sciences Laboratory. The Energy Sciences dedicated to advancing technology through research, development, testing, and evaluation. Hydrogen fuel cell systems. Researchers are using these laboratories to develop advanced hydrogen detection techniques. Blah, 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 blah. Okay, so that is a career. It's called, what did we type in? So fuel systems development. Okay, one possible career that where we use this idea is applied is fuel systems development. Is a fuel systems developer. Okay. And it was this one that we tapped in. Okay, hydrogen fuel systems, transporting energy. At ESIF, researchers examine how electrolyzers, hydrogen storage, and fuel cells and other hydrogen technologies can be integrated in today's energy systems. Okay, so there's your moneymaker right there. So this person does what? Where did I say it's? Oh, this person examines how electrolyzers, hydrogen storage fuels, and other hydrogen technologies can be integrated in today's energy systems. Okay, so electrolyzers examines how electrolyzers, hydrogen something, where is it? Storage, fuel cells, and other hydrogen technologies can be integrated, or integrated means weaved into our current fuel systems. Okay. All right. So that's one possible career. So what you want to do is, here's your source, and it's an internet source. So I'm going to copy and paste this URL into source into my right there. Okay. So this person, okay, so one possible career where this idea can be applied is a fuel systems developer. This person examines how electrolyzers, hydrogen storage, fuel cells, and other hydrogen technologies can be weaved into our current fuel systems. Boom. There you go. All right, there's my source. So let's see. This is a detailed paragraph that explains your hypothesis and explain why your data tells you possible sources of error, how this slide can be improved, and career. Don't give me a numbered list. You may not use any information that is not your original work unless it is cited. I take plagiarism very seriously, and you will receive a 0, parent contact, and an opportunity to redo the assignment the first time this happens. If there is a second time, you're going to receive a 0 with no opportunity to redo and an office referral. I do run these assignments through a plagiarism checker. Okay, yeah, I do run these through a plagiarism checker. So you're also not allowed to use or copy any part of a classmate's lab and call it your own. Both parties involved, the copier and the copyee, will be equally at fault. You can't, I didn't know they were copying. No, you do know because you gave it to them. Okay, so don't do that. I see this all the time. And I find it, and I do hold you accountable. So don't do this, please. Please don't do that to yourself. All right, so those are the instructions. Delete them out. There you go. This is my lab hand-in, my lab write-up that I'm going to hand in. except for what I didn't do for you is the post-lab questions. That's the only thing I didn't do for you. So you should pretty much get 100 on this because you're going to answer these post-lab questions. You're going to fill in your data here. You're going to answer these post-lab questions. You're going to draw your graph. You're going to include it. You're going to write your conclusion just like this, only don't copy mine because your hypothesis may not have been the same. Okay. And you can't use the examples. You can't use this career. You have to come up with another one. Oh, one more thing that I do want to tell you, and I hope you watch this all the way to the end. On this career, you cannot say a chemistry teacher. You cannot say a chemistry professor. You cannot say a teacher. You have to come up with something that doesn't use teaching because, yeah, any lab we do, you could say a teacher, a chemistry teacher, or a chemist. You can't say chemist. That's too broad in general. You have to come up with a specific career that uses what we're talking about in this lab. Okay. So if you say a chemistry teacher, nah. If you say a professor, you don't get credit for that. Also, you do not get credit for this section if you do not include your source. If you don't include your source, you don't get credit for the career. All right, so this conclusion is 20 points. 5 points for your hypothesis being supported or unsupported and data to support that statement. 5 points for possible errors. 5 points for this lab being changed, one way it could be changed or improved, and 5 points for your career with your source. Okay, with your source. Now I want to show you something, and I see this all the time, and I don't accept that. So if I were to come over here and I just Googled fuel systems development, and I just looked at this, and then it says hydrogen and fuel systems research and energy. Says if I just wrote that down, okay, and then I copied this right here as my URL, I want to show you what it does. See all of this gobbledygook on you? A lot of times you'll see a bunch of percent signs, percent this, percent that, percent. No. That's you copying what you Googled right here. That's this. That's not you actually going to this website and copying and reading what it says here about it and copying this URL. So if you give me this garbage, you do not get credit. That is not doing research. One Google search where you have all of these hits and you just read this little introductory sentence here does not count as research. Okay. I want you to actually go to the website and do a little bit of reading. Now you don't have to read the whole thing because, unless you want to, because these are very detailed. Okay. But you need to read and make sure that this career fits. Like we read a few of these paragraphs. We even read some other websites and was like, nah, that's not what I want. But we did find this website and I read some stuff here. I think I read some stuff down here and decided, yeah, that's a career. I just quick little research. I don't mean you have to research for hours. Okay. But giving me this garbage right here, no, that doesn't work as citing your source. It's got to be a specific website that you go to. Okay? So do not do that. All right, that's it. So that's your lab write-up. Finish that, get that turned in, and do all of your other labs that we have throughout the year this exact same way. Okay? And also, I want to tell you that when you're watching these videos, let me find the video just like this. This comes from my YouTube channel. And if you click on the title there, it will take you. It can help you express your ideas clearly for free. Wow. It will take you to my YouTube channel, okay, where you can, like Holodeck Arch is the YouTube channel, and see it says Holodeck Arch here. You can subscribe. And when you subscribe, it's going to, anytime I do a new video, if you click this bell right here where you receive all notifications, you're going to know when I put up videos, new videos for you to watch, because it's going to notify you, right? And sometimes what I'll do is if a student asks me questions about something that we're doing in class, like they don't understand a problem that we're doing, I'll make a quick video tutorial on how to work through that problem and post it up here for that student. And so you can come here and watch this video. All right, so you'll be notified when I put up new videos. So if you just go to click on this and go to my holodeck arch, I have so many videos already up on different things that we're doing throughout the year, the notes that we're doing. And so that's where you can find all this. So you can subscribe to my channel and be notified, click this bell and be notified when I put up new videos. And it could be something that you have a question on, you never know. And so there's that. Okay. So thank you for watching and we'll see you in class.